In the last video, we talked about arithmetic sequences and how you could determine if a sequence was arithmetic. All arithmetic sequences have a common difference. In this video, we're going to talk about geometric sequences in series and how you recognize them, what makes it geometric, how do you determine a particular term of the sequence, and then how do you find the sum of either a finite or an infinite geometric series. Okay, so again, arithmetic had a common difference, which meant that all the terms either added or subtracted the same number to get the next term. To be a geometric sequence, it's got to have a common ratio. So if I take the consecutive terms and I divide, so the second term divided by the first term, or the third term divided by the second term, etc., should give me the same number. And that is called the common ratio. We're going to let R represent the common ratio, just like D was the common difference for arithmetic. So in this example, if you'll notice, if I take the second term divided by the first term, I get 3 for the ratio. If I take the third and the second, 45 over 15 is still 3. 135 divided by 45 is again 3. So this time I have a common ratio and my R is 3. So if my terms are increasing this time, then my ratio is going to be a number that is greater than 1. If my terms are decreasing, if they're getting smaller as I go on, then my common ratio is going to be smaller than 1. Okay, so we are going to look at several sequences, and I want you to determine are they geometric or not. And if they are, find your common ratio. So if you'll pause on each slide, decide your answer, and then start again. Okay. Is this sequence geometric? Well, if I look at the terms, if I take the first two, 12 over 24 would equal a half. 6 over 12, again, gives me 1/2. 3 over 6 is 1/2. So I do have a common ratio of 1/2, and it is geometric. Okay. And again, notice that the ratio is less than 1 because my terms are decreasing. They're getting smaller. Okay, again, pause the video, decide on your answer. Okay. This sequence is not geometric because if I take the terms 4 over 1 and 9 over 4, those are not the same. So the ratio is not the same, therefore it is not geometric. This one also is not arithmetic because if I add, this is a +3, then a +5, +7, so it doesn't have a common difference either. So this one is neither arithmetic nor geometric. Okay, pause to get your answer. Okay, again, this sequence is not geometric. If I divide to find my common ratio, 14 over 8 and 20 over 14, this would be 10 over 7. This one would be 7 over 4. Those are not equal to each other, so it is not geometric. If you look closely, these are adding 6 every time, which means that this one would be arithmetic because it has a common difference of 6. Okay, and again, pause your video. Okay, this sequence is geometric. If I take the consecutive terms, 1/9 divided by 1/3, -1/3, remember when you divide fractions you have to flip and multiply, would give you a -3/9 or a -1/3. You get the same thing if you take the second and third terms, so -1 over 27 divided by 1/9 would be times 9 over 1. Again, reduces to -1/3. And if I check the next two, the same thing happens. So yes, this is geometric. And my ratio is negative, or my common ratio is -1/3. Notice my terms are getting smaller as I go on, which again tells me my R should be less than 1, and this time it is. The negative makes your terms alternate in sign. Okay, now how do you find a particular term? of the geometric sequence. Here is the formula you're going to use. I would like you to highlight this formula. Okay, now let's talk about what those variables mean. Okay, a sub 1 is talking about the first term of your sequence. Okay, the r, again, is common ratio. The n is the number of term. Okay, and then a sub n is how we denote the nth term. That's kind of our generic. It's like using a variable x to represent unknown numbers. So our nth term, or any term that we want to find, is a sub n. Okay, let's look at an example of how to use this. We want to find the nth term of the given sequence. So we're going to take our formula, a sub n equals a sub 1 times r to the n minus 1. And in this formula, I need to substitute for a sub 1 and for r. The n is your variable and a sub n is your general statement for nth term. Okay, so a sub 1, remember, was first term. So that in this case is 3. Okay, so I would have a sub n equals 3 times r to the n minus 1. R is our common ratio. So if we take our terms and we divide 6 over 3, or 12 over 6, or 24 over 12, all of those will reduce to 2. So 2 is my common ratio. And this is our equation to find the nth term. So we're going to stop there. Now here's a common mistake that happens every year. Okay, a lot of people like to write that as 6 to the n minus 1. That is not correct. Think about your order of operations. Exponents get done before the multiplication. So you can't say 3 times 2 and then raise it to the power. You have to do 2 to the power first, then times 3. So you're going to have to leave it in this form. 3 times 2 to the n minus 1. Okay, let's look at a little bit different example. We're going to this time find a specific term, the 15th term of the geometric sequence whose first term is 20, common ratio is 1.05. Okay, so if the first term is 20, that's our a sub 1. The common ratio, 1.05, that's our r. And the 15 is the number of the term we're looking for, so that's our n. So our formula again, a sub n equals a sub 1 times r to the n minus 1. Okay, so the 15th term would be a sub 15. I'm going to put in 20 for a sub 1. R is 1.05. And then 15 minus 1, because 15 was the n. So 15 minus 1 is 14. And you're going to raise 1.05 to the 14th power first. And then multiply that answer times 20. And when you put this in the calculator, you're going to end up with approximately 39.599. If you have to round, go to at least 3 decimal places. Okay. Okay, so that's how you find a particular term, or you find a formula for a geometric sequence. Now let's talk about a series, the sum of a finite geometric series. Finite simply means that we have a specific number of terms. So we're going to add up the first 15 terms or the first 25 terms. Okay, it's not an infinite series where we're trying to add up all of the terms in the sequence. So highlight this formula. And again, let's talk about what these terms mean. Okay, S sub n stands for the sum of the first n terms. So if it's S sub 10, I'm trying to find the sum of the first 10 terms. A sub 1, again, is your first term. Okay, R is your common ratio. And n, again, is the number of terms. So if I'm trying to find the sum of 10 terms, my n is 10. Okay, let's look at an example. Now, most of these problems will look like summation problems. And you have to recognize that this is, in fact, a geometric sequence because it's in the form a times r to the n minus 1, except ours is not n minus 1 this time, it's just n. Okay, so what we're going to do is we're going to use our formula. Okay, and how many terms am I trying to add up? Well, if you look at the top number, I'm going from 1 to 12, so I'm finding the sum of the first 12 terms. Okay, and then I want a sub 1, 1 minus r to the n, over 1 minus r. So I need to know what a sub 1 is, and I need to know what r is. Okay? To find a sub 1, if you will plug in 1 into the formula, so 4 times 0.3 to the first, 0.3 to the first is just 0.3, times 4 is 1.2. So our first term would be 1.2 if we had them listed out. So the sum of 12 terms is 1.2 times 1 minus, our r is always the number raised to the power. Okay, so 0.03 is the r, or 0.3. And then n, again, we said was 12 because the top number tells us how many terms we're adding up if I'm going from the first term to the 12th term. Okay, and then over 1 minus 0.3. Okay, so we're going to start in the parentheses, and we're going to do the top of the fraction and the bottom of the fraction separately. Okay, so when you put this in the calculator and you multiply all of this out, you will come out with approximately 1.714. Again, if you have to round, go to 3 decimal places. Okay, we've got one more formula to look at, and that is the sum of an infinite geometric sequence or series. And you can only do this if the absolute value of your common ratio is less than 1. Otherwise, this formula will not work because it will just give you bigger and bigger and bigger numbers. Okay, so you can only find the sum of a geometric series if the r is less than 1, absolute value of the r. Okay, and again, we've only got 2 variables in this one. S is sum. The a sub 1 is the first term. And again, the r is the common ratio. Okay, so let's look at an example. Highlight this formula in your notes. Okay, find the sum of the infinite series given. So we're not just adding up the first 4 terms, we're adding up every term, which we can't list out. But again, this formula will work if your absolute value of your r is less than 1. So let's find the r first and make sure that the formula is applicable. So to find our r, we're going to take the second term divided by the first term, 0.3 divided by 3 should come out to be 0.1. Okay, if I do the same thing here, 0.03 divided by 0.3 would equal 0.1. And again, I could keep going, so my r is always coming out to be 0.1, which is less than 1, so we can use our formula. So S equals a sub 1 over 1 minus r. The a sub 1, the first term, is 3. And we're going to do 1 minus 0.1 for our r. So we've got 3 over 0.9. Okay, and I don't like that fraction and decimal, so let's fix that. And we're not going to get a decimal this time. Let's actually get a fraction answer. Okay, so this is really 3 divided by 9/10. So we're going to take the bottom and do the reciprocal and multiply. So 3 over 1 times 10 over 9 is 30 over 9, or 10 over 3. And that would be the sum of the whole sequence. Which, if you just look at what we've got here, if you add those terms that are listed, we would have 3.333, and it keeps repeating. 3.3 repeating is the same thing as 3 1/3, which is 10 over 3. Okay, so this formula gives you a way to find the sum of an infinite series. Okay, if you have questions, put a question mark beside anything you were unclear about, and you can ask in class. And be sure that you left room for questions and summaries in Cornell note format.